Have you ever stood beneath the vast ink-black canopy of the night sky, feeling the quiet earth beneath your feet, and wondered why the universe seems so peaceful from our tiny vantage point? We walk upon our familiar world, experiencing gravity as a gentle, guiding hand that keeps our oceans in their beds and our feet firmly planted on the ground. We think we understand the nature of weight. We think we understand what it means for something to be solid, heavy, or dense. A piece of iron feels substantial in our hands. A stone sinks effortlessly to the bottom of a quiet pond. Our everyday human experience builds a comfortable intuition about how matter behaves. But the cosmos is vast, ancient, and filled with mysteries that casually shatter our terrestrial illusions. What if I told you that drifting in the deep silence of space, millions of light years away, there are silent monuments to cosmic violence that defy every single rule your senses have ever taught you? Imagine an object so profoundly compressed, so unimaginably dense, that if you could somehow extract a single piece of it no larger than a tiny cube of sugar, that tiny fragment would weigh more than every single human being on Earth combined, multiplied by 1,000. This is not dramatic storytelling or the realm of science fiction. This is the rigorous, astonishing reality of the universe. This is the neutron star, a cosmic enigma that forces us to question the very fabric of reality. Before we journey further into this mind-bending mystery, I want to take a brief moment to welcome you. I am Walter, the explorer, and together we travel through the endless wonders of the cosmos. I have noticed that roughly 73% of the wonderful people who watch these journeys have not yet subscribed to the channel. If you find peace and curiosity in these sleepy scientist stories, please consider subscribing. It helps our community grow tremendously and ensures we can continue exploring the infinite universe together, one gentle step at a time. Now, let us return to the quiet dark and set our sights on one of the most extreme environments ever discovered by human science. To truly comprehend the mind-boggling nature of a neutron star, we must first travel back in time to witness its magnificent, violent birth. A neutron star does not form gently. It is born in the ultimate crucible of cosmic destruction, the dying breath of a true stellar giant. Imagine a star many times more massive than our own familiar sun. For millions of years, this enormous sphere of incandescent plasma has lived a life of delicate, perfect balance. Deep within its ancient core, nuclear fusion has been raging, a continuous explosion that pushes outward with unimaginable force. Gravity, the relentless sculptor of the cosmos, constantly pulls all that massive material inward, trying to crush the star under its own astronomical weight. As long as the star has nuclear fuel to burn, the outward push of fusion perfectly matches the inward pull of gravity. It is a beautiful, stable equilibrium that allows the star to shine steadily across the vast gulfs of space. But the universe is a place of constant change, and no star can burn forever. Eventually, after millions of years of shining, the giant star exhausts its supply of hydrogen. It moves on to fuse helium, then carbon, then oxygen, silicon, and other heavier elements, creating the very building blocks of the universe in its fiery heart. But this process cannot continue indefinitely. The star eventually creates a core of solid iron, and iron is the cosmic ash of nuclear fusion. Fusing iron does not release energy. It absorbs it. In a fraction of a single second, the delicate balance that has sustained the star for epochs is suddenly and violently broken. The fusion engine shuts off. Without the outward pressure of nuclear fusion to support it, the entire immense weight of the outer layers of the star comes crashing down upon the core. Gravity wins the eternal battle, and it wins with terrifying speed and absolute finality. The core, which might be roughly the size of our entire planet Earth, is suddenly compressed into a sphere merely 10 to 15 miles across. The speed of this collapse is staggering, reaching significant fractions of the speed of light. As the outer layers of the star hit this suddenly incredibly dense, newly formed core, they bounce off in an explosion of incomprehensible magnitude. This is a supernova, one of the most energetic and luminous events in the known universe. For a brief, glorious moment, a single exploding star can outshine an entire galaxy of 100 billion stars. It sends shock waves rippling through the interstellar medium, scattering those newly forged heavy elements, the carbon, the oxygen, the iron, out into the dark, seeding the cosmos with the materials that will one day form new stars, new planets, and perhaps, eventually, life itself. But while the supernova is a brilliant, blinding farewell, our journey today is not about the light that escapes. It is about the dark, silent remnant that is left behind in the heart of the expanding nebula. When the cosmic smoke clears, sitting quietly in the center of the devastation is the neutron star. It is the collapsed core of the giant star, a monument to the overwhelming power of gravity. To understand what has happened to the matter inside this remnant, we have to abandon our everyday understanding of atoms. You probably learned in school that atoms are mostly empty space. An atom consists of a tiny, dense nucleus made of protons and neutrons surrounded by a vast, buzzing cloud of electrons. If you were to imagine the nucleus of an atom as the size of a small marble sitting in the center of a massive football stadium, the electrons would be tiny gnats buzzing around the very highest seats in the grandstands. Everything you have ever touched, everything you have ever seen, your own body, the device you're using right now, the chair you're sitting on, it is all almost entirely empty space. The illusion of solidity comes from the electromagnetic forces between those electron clouds pushing against each other. But inside the collapsing core of a giant star, gravity becomes so intensely powerful that it easily overcomes those electromagnetic forces. The empty space is crushed out of existence. The electrons are violently forced directly into the protons, merging together to create neutrons. The entire core of the star, a mass equivalent to 1.5 to 2 times the mass of our entire sun, is compressed until it is nothing but a solid, incredibly tightly packed sphere of neutrons. It is essentially a single, gigantic atomic nucleus the size of a small city. This is where the numbers stop making sense to our terrestrial brains. Our sun is immense, over 800,000 miles across. You could fit more than 1 million Earths inside it. Now, imagine taking the mass of that sun, adding another half of a sun to it, and crushing all of that material into a sphere that could easily fit within the city limits of a place like London or New York. The resulting density is beyond human imagination. A single teaspoon of neutron star material would weigh roughly 10 billion tons. That is approximately the weight of an entire mountain like Mount Everest, compressed into a volume no larger than a simple teaspoon you might use to stir your morning coffee. If you were to accidentally drop that teaspoon of neutron star material here on Earth, it would not just fall to the ground. It would tear through the crust of our planet like a hot knife through the thinnest paper, plunging straight down toward the center of the Earth, pulled by gravity, leaving a trail of absolute devastation in its wake. But out there, in the quiet vacuum of space, this incredible object simply exists, spinning silently in the dark. It is a profoundly humbling realization. As the great astronomer Carl Sagan once reminded us, we are made of star stuff. The very atoms that compose our bodies were forged in the hearts of ancient stars that lived and died long before our world was born. We are intimately connected to the cosmos, not merely observers standing outside of it, but participants in its grand, unfolding story. The iron in your blood, the calcium in your bones, all of it traces its lineage back to the fiery cauldrons of stellar cores and the explosive fury of supernovas. Knowing this transforms our perspective. When we look up at the night sky, we are not just looking out into the cold void. We are looking back into our own deepest history. The neutron star, then, is not just a distant, terrifying anomaly. It is a monument to the processes that made our existence possible, a quiet tombstone marking the site where the heavy elements of life were forged and scattered into the cosmic wind. Because the original giant star was likely spinning, and because of the law of conservation of angular momentum, the same principle that makes an ice skater spin faster when they pull their arms in, the sudden dramatic collapse causes the newly formed neutron star to spin at terrifying speeds. Some of these ancient, silent spheres rotate hundreds of times every single second. Imagine a sphere packing the mass of our sun, spinning so fast that its equator is traveling at a significant fraction of the speed of light. The sheer mechanical forces trying to tear the star apart are almost unfathomable. Yet the crushing grip of gravity holds it together in a perfect, smooth sphere, and smooth it is. The gravity on the surface of a neutron star is hundreds of billions of times stronger than the gravity we feel here on Earth. If you could somehow stand on its surface, though you would be instantly crushed into a layer of atoms less than a millimeter thick, you would find a landscape that is flatter than a perfectly polished mirror. The gravity is so immense that any irregularity on the surface of a neutron star could not be taller than a fraction of an inch before the sheer weight of it would cause it to collapse and flow perfectly flat. It is a world of absolute, unyielding extremes, a place where the laws of physics are pushed to their absolute breaking points, challenging scientists to look deeper into the equations of quantum mechanics and general relativity. As we stand at the edge of this incredibly smooth, mind-bending surface, preparing to dive into the even more mysterious and paradoxical depths of the star's interior, we must pause and take a breath. The universe is vast, and its mysteries are deep. We are just beginning to peel back the layers of this cosmic onion, stepping from the realm of the extremely dense into the realm of the absolutely bizarre. Have you ever walked along a quiet beach at night, feeling the solid, familiar grains of sand beneath your feet, and wondered what it means for something to be truly solid? We trust the ground we walk on. We build our homes, our sprawling cities, and our entire lives upon the gentle, unspoken assumption that the earth beneath us will always remain firm and stable. When we hold a heavy stone in our hands, we feel the comforting weight of certainty. But as we continue our quiet journey into the deep cosmos, approaching the silent, spinning surface of the neutron star, we must gently lay aside everything we thought we knew about the solid world. The crust of this ancient stellar remnant is a place where the familiar rules of chemistry are completely warped into something alien, a landscape of frozen extremes that defies human imagination and challenges our deepest understanding of reality. It is a place of profound mystery where the universe tests the absolute limits of matter. Before we take our first gentle step onto this mind-bending surface, I want to pause for just a moment in the quiet dark and say hello once more. I am Walter, the explorer, your gentle guide through these peaceful mysteries of the infinite universe. I have noticed that exactly 73% of the wonderful, curious souls who join us on these cosmic journeys have not yet subscribed to the channel. If you are finding a moment of calm and wonder in our time together, please consider subscribing. It helps our quiet community grow tremendously and allows us to keep exploring the vast, endless night together. Now, let us return to the smooth, terrifyingly perfect surface of our neutron star and begin our descent. As we descend toward the star, drifting softly through the absolute, freezing silence of space, we encounter something utterly counterintuitive, a paradox that challenges our common sense. Despite being a dead, crushed remnant of a once glorious sun, the neutron star actually possesses an atmosphere. But do not try to imagine the soft, breathable air of our home planet, nor the thick, swirling clouds of a gas giant like Jupiter. This atmosphere is a mere whisper, a ghostly, glowing halo of plasma that is incredibly thin. Imagine that phenomenon for a moment. An entire atmosphere containing the very lightest elements in the known universe, primarily hydrogen and helium, compressed by relentless gravity into a layer that is perhaps only a few inches thick. The gravity here is so profoundly intense, pulling with a force hundreds of billions of times stronger than the familiar gravity that keeps your feet resting gently on your floor, that it flattens the atmosphere into an almost two-dimensional film. Yet, despite being so unimaginably thin, this atmosphere is blazing hot, glowing with a fierce, invisible energy. The temperature in this whisper of air is measured in the millions of degrees, radiating powerful X-rays out into the cold, empty void of the cosmos. It is a paradox that sparks a deep sense of wonder, a whisper-thin layer of gas trapped eternally in an iron grip, burning quietly with the residual heat of a million ancient suns. It is here, in this razor-thin threshold between the empty cosmos and the hyperdense star, that we begin to realize just how alien this environment truly is. We are crossing a sacred boundary into a realm where matter is pushed to the absolute brink of its physical endurance. Plunging beneath that blazing, paper-thin atmosphere, we finally touch the true surface. We have reached the outer crust of the neutron star. On Earth, our crust is a chaotic, beautiful, ever-changing mosaic of different rocks, minerals, and slowly shifting tectonic plates. It is constantly moving and reforming over millions of years of geological time. But the crust of a neutron star is a masterpiece of terrifying, absolute, crystalline order. It is composed primarily of iron nuclei, the exact same iron that flows silently through your veins right now, carrying the oxygen that fuels your thoughts and dreams, but arranged in a configuration that exists nowhere else in the universe. Because the gravity is so overwhelmingly powerful, these iron atoms are squeezed together tighter than any material we could ever hope to create in our most advanced terrestrial laboratories. The soft, buzzing electron clouds, which normally keep atoms spaced comfortably apart in a gentle electromagnetic dance, have been utterly crushed and stripped away. What remains is a perfectly ordered, ultra-dense crystal lattice of bare atomic nuclei, locked forever in a rigid, frozen embrace. The pressure is so extreme that this material is billions of times stronger than the hardest, most resilient steel ever forged by human hands. It is a solid so absolute that it makes diamonds seem as soft and fragile as sponge sugar floating on the wind. If you were to gently tap this surface, it would ring like a massive cosmic bell, vibrating with terrifying frequencies that would instantly shatter any known material. This crust is the impenetrable armor of the neutron star, a silent, unyielding shell that locks away the deeper mysteries waiting in the dark below. It is ancient, forged in the catastrophic fires of a dying giant, and it will remain in this frozen state for trillions of years, waiting patiently in the silence long after the last normal stars have burned out. But our journey does not stop at the surface, for the universe always beckons us deeper into the mystery. As we sink deliberately into the crust, moving down just a few feet, or perhaps a single mile into this bizarre, compressed world, the pressure continues to mount with an intensity that defies logic. The gentle calm we seek is utterly absent here. Instead, there is only the silent, crushing weight of an entire star pressing inward. The density increases exponentially with every fraction of an inch we descend. As we move deeper into the dark, the iron nuclei that form the crystal lattice begin to experience a profound transformation. The pressure is so immense that it begins to force loose electrons directly into the protons of the iron nuclei, neutralizing their charge and transforming them into even more neutrons. The atomic nuclei become engorged, heavy, and incredibly rich in neutrons, forming strange isotopes of familiar elements that would instantly decay and fall apart if they were somehow brought back to the safety of our world. But here, locked tightly in the eternal embrace of the star, they are perfectly stable. We are witnessing the limits of nuclear physics unfolding before our eyes, a place where the periodic table of elements is warped and rewritten into unrecognizable new forms. It is a profound mystery, a cosmic puzzle that dedicated astronomers from agencies like the National Aeronautics and Space Administration and the European Space Agency spend their entire lives trying to unravel. They use massive radio telescopes and sensitive orbital X-ray observatories to listen to the faint, ancient whispers of these stars, trying to deduce what happens to matter when it is squeezed far beyond the limits of earthly comprehension. The true wonder of it all is that we can sit here safe on our quiet planet, and use the power of human thought to peer inside a monstrous object thousands of light years away in the deep silence of the void. As we travel even further down, approaching the hidden boundary between the deep crust and the unimaginable swirling core, the pressure becomes so extreme that even the rigid, perfect crystal lattice of atomic nuclei begins to fail. The nuclei are squeezed so tightly together that they have no choice but to begin to touch, to merge, to stretch, and to deform. And here, in the deep, silent, crushing dark of the inner crust, we encounter one of the most profoundly strange states of matter in the entire cosmos, the nuclear pasta. This is not a playful joke. It is a serious scientific theory describing how matter behaves under absolute extremity. First, the spherical nuclei are crushed by the pressure into long, dense cylinders, a formation physicists gently refer to as the spaghetti phase. As the pressure continues to mount, these cylinders are flattened out into vast parallel sheets, known as the lasagna phase. Finally, as we reach the bottom of the crust, these sheets merge into a solid, continuous mass filled with long, cylindrical voids, a final phase whimsically called the anti-spaghetti phase. This nuclear pasta is believed to be the strongest material in the known universe, up to 10 billion times stronger than steel. It is a boundary layer, a transition zone, where individual atoms lose their identity entirely, preparing to dissolve into the terrifying ocean of the core below. The existence of this nuclear pasta is a beautiful testament to the infinite creativity of the physical laws that govern our universe. Even in the most hostile, crushing environment imaginable, matter finds a way to organize itself into intricate, beautiful patterns. It is a gentle reminder that the cosmos is not just a place of chaos and destruction, but also a place of hidden order. As we stand at the final edge of the inner crust, looking down into the dark depths of the neutron star's core, we must gather our courage and prepare to leave the familiar realm of atoms behind forever, stepping into a mystery so deep that even modern science struggles to light the way forward into the endless dark. Have you ever sat quietly by the edge of a gently meandering stream, watching the clear water flow smoothly over the smooth, ancient stones, and wondered about the hidden nature of resistance? We are intimately familiar with friction in our everyday lives. When we slide a book across a wooden table, it eventually slows down and stops. When the wind blows through the trees, it loses energy to the rustling leaves. Our entire human experience is built upon the gentle, continuous push and pull of surfaces interacting, a world where every movement requires effort and everything eventually comes to a quiet rest. We assume that this slow loss of energy is a fundamental, inescapable rule of reality. But as we continue our meditative journey deeper into the impossible depths of the neutron star, we must leave this comforting intuition behind. We are about to cross the threshold from the crushing, solid crystal of the inner crust into a liquid realm so profoundly alien that it defies the very definition of a fluid. We are stepping into the dark, silent ocean of the outer core, a place where quantum mechanics, the strange rules that normally govern only the smallest subatomic particles, suddenly rules over a vast macrocosmic sea. It is a realm of absolute extremes, a place of infinite mystery that forces us to question what we truly know about the physical universe. Before we plunge into this frictionless, glowing ocean of neutrons, I want to gently welcome you back to our shared space of wonder. I am Walter, the explorer, your quiet companion on this voyage through the magnificent and terrifying cosmos. I have noticed that exactly 73% of the beautiful, inquisitive minds who join us on these relaxing scientific journeys have not yet subscribed to our channel. If you find comfort and peace in these sleepy scientist stories, please consider subscribing. It helps our quiet little community grow and ensures that we can continue to embark on this endless journey of discovery together, exploring the deep mysteries of the universe. Now, let us take a deep breath and let go of the solid world, allowing ourselves to sink softly into the crushing liquid heart of the dead star. As we leave the bizarre, twisting structures of the nuclear pasta behind, the immense pressure of the star finally shatters the last remaining atomic boundaries. We are no longer dealing with atoms, or even the crushed remnants of atomic nuclei. We have entered a vast, churning ocean composed almost entirely of raw, unbound neutrons. This is the outer core of the neutron star, a liquid sphere that contains more mass than our entire sun, yet is compressed into a space small enough to walk across in a single afternoon. But this liquid is nothing like the water in our gentle streams or the vast rolling oceans of our home planet. Because the density here is so astronomically high, the neutrons are forced into a state of matter known as a superfluid. To understand the sheer, mind-bending wonder of a superfluid, you have to imagine a liquid that possesses absolutely zero internal friction, none whatsoever. If you were to take a cup of this neutron superfluid and give it a gentle stir, it would never, ever stop spinning. It would swirl in a perfect, silent vortex for billions or even trillions of years, long after the last stars in the universe have faded into the cold, endless night. The concept of a frictionless liquid challenges our deep-seated intuition about how the physical world operates. On Earth, we rely on the continuous friction of fluids to fly our airplanes, to sail our ships, and to pump blood through our own veins. But here, deep within the crushed heart of a dead giant, those rules are suspended. This superfluid ocean is a macroscopic quantum phenomenon. The strange, ghostly rules of quantum mechanics, which normally apply only to individual microscopic particles, are suddenly dictating the behavior of a liquid mass heavier than an entire solar system. The neutrons in this vast sea are no longer acting as billions of separate, individual particles bouncing off one another. Instead, the crushing pressure and the extreme conditions force them to overlap and merge their quantum identities, acting together as one single, unified quantum entity. It is a harmonious, silent dance of matter on a scale that beggars the imagination. The sheer, quiet beauty of this concept is staggering. In the absolute, terrifying dark of this hyper-dense core, there is a perfect, frictionless harmony, a state of unyielding grace that exists nowhere else in the known cosmos. But the wonder of the outer core does not end with the frictionless sea of neutrons. Scattered throughout this vast, dark ocean are a relatively small number of protons and electrons that managed to survive the initial catastrophic collapse of the giant star. And just as the neutrons have been forced into a superfluid state, these remaining protons are forced into an equally bizarre and fascinating condition. They become a superconductor. We use superconductors here on Earth in our most advanced laboratories, cooling materials down to near absolute zero to allow electrical currents to flow without any resistance. It is a delicate, fragile state that is incredibly difficult to maintain. Yet here, in an environment where temperatures are measured in the millions of degrees, the incomprehensible crushing pressure achieves the same miraculous effect. The protons form a perfect, flawless electrical superconductor. This means that electrical currents can flow through the heart of the neutron star for billions of years without ever losing a single fraction of a percent of their energy to heat or resistance. It is a perpetual motion machine of electrical charge, hiding quietly in the darkest, most inaccessible place in the universe. The existence of this superconducting ocean of protons has profound, universe-shaking implications, because moving electrical charges generate magnetic fields, and the magnetic fields generated by the swirling, frictionless currents inside a neutron star are the strongest magnetic forces ever discovered by human science. Our gentle home planet, the Earth, possesses a quiet, invisible magnetic field that guides our compass needles, protects our atmosphere from the harsh solar wind, and paints the beautiful, shimmering auroras across our northern and southern skies. We owe our very existence to this gentle magnetic shield. But the magnetic field of a typical neutron star is trillions of times stronger than the magnetic field of the Earth. In a specific, rare class of neutron stars known as magnetars, this field can be up to 1,000 trillion times stronger. If a magnetar were to somehow magically appear halfway between the Earth and our moon, its magnetic field is so catastrophically intense that it would instantly wipe clean every single magnetic strip on every credit card on our planet, and it would violently pull the iron atoms directly out of the hemoglobin in our blood from hundreds of thousands of miles away. The sheer power of these magnetic fields is a humbling reminder of the terrifying, awesome forces that hide in the quiet dark of the cosmos. Yet, there is a profound elegance to it all. The intricate interplay of the superfluid neutrons and the superconducting protons creates a complex, tangled web of magnetic energy that permeates the entire star, occasionally snapping and reconfiguring in violent starquakes that send invisible ripples of energy cascading across the infinite void, sometimes reaching our delicate instruments here on Earth after a journey of thousands of years. We detect these faint, ancient whispers using our most advanced satellites, built by brilliant minds at agencies like the National Aeronautics and Space Administration. When these signals wash over our world, they carry with them the secrets of this impossible, frictionless ocean. They remind us that our knowledge of physics is still growing, still evolving, as we reach out into the vastness of space. As we drift silently in this perfect, swirling quantum sea, feeling the weight of an entire crushed sun pressing down upon us, we might feel a deep sense of existential smallness. We are fragile creatures of flesh and bone, adapted to a narrow, gentle sliver of existence on the surface of a tiny, rocky world. The environment we are exploring now is so hostile, so utterly alien to our terrestrial experience, that it seems impossible to truly comprehend. And yet, the very fact that we can imagine it, that we can use our mathematics, our physics, and our boundless human curiosity to pierce the dark and understand the frictionless, superconducting heart of a dead star, is a testament to the remarkable power of consciousness. We are the universe waking up and attempting to understand its own most extreme mysteries. We are the cosmos seeking peace in the face of its own terrifying power. The journey through the neutron star is not just a scientific exploration. It is a philosophical meditation on the nature of reality and our place within it. But as deep as we have traveled, as strange and wondrous as this superfluid ocean may be, we have not yet reached the end of our journey. Beneath the outer core lies a mystery so profound, a place so incredibly dense, that the very laws of physics as we understand them begin to break down entirely. We are approaching the inner core, the deepest, darkest, most inaccessible heart of the star. It is a place where even the reliable, sturdy neutrons might not be able to survive the crushing pressure. What lies at the very center of this cosmic monument? What happens to matter when it is squeezed to the absolute, theoretical limit of its existence? To find those answers, we must gather our courage once more, letting the frictionless currents carry us further down into the profound, absolute silence of the infinite unknown. The mystery deepens, and the universe gently beckons us forward. Have you ever stood at the edge of a deep, ancient forest as the sun dips below the horizon, watching familiar shadows dissolve into absolute dark, and wondered what secrets lie hidden where light can never reach? We are creatures of the surface, adapted to a world illuminated by our gentle sun, comfortable with the boundaries of what we can see and touch. When we gaze into a deep cave or the abyssal trenches of our oceans, we feel a quiet thrill, realizing our everyday reality is just a brightly lit veneer over a world of profound mystery. We instinctively know there are places where the rules change, where the familiar gives way to the utterly unknown. As we continue our meditative journey, sinking deeper into the heart of the neutron star, we leave the illuminated shores of established physics far behind. We are about to cross the final threshold into the inner core, the deepest, most inaccessible abyss in the known universe. It is a place so unbelievably dense that the very building blocks of matter begin to break down, melting into a strange, quantum soup that challenges the greatest minds on our planet. Before we take this quiet step into the ultimate dark, I want to take a gentle moment to welcome you back to our shared exploration. I am Walter, the Explorer, your quiet guide through the vast, endless wonders of the cosmos. I have noticed that exactly 73% of the wonderful, curious people who join us on these peaceful journeys through the infinite universe have not yet subscribed to our channel. If you are finding a moment of calm and a spark of wonder in these sleepy scientist stories, please consider subscribing. It helps our gentle community grow tremendously and ensures that we can continue to drift together through the mysteries of space, seeking peace in the quiet dark. Now, let us return to the crushing, silent depths of the star and confront the ultimate mystery that lies at its very center. As we sink below the frictionless ocean of superfluid neutrons making up the outer core, the pressure mounts to levels beyond human comprehension. The density here is so profound that if you compress the entire mass of the human race, all 8 billion of us, into a space the size of a single sugar cube, you would only just begin to approach the conditions found in this alien realm. We are approaching the very center of the star, a region perhaps only a mile or two across, but containing a mass that warps the fabric of space-time into a steep gravity well. Here, the comfortable laws of physics that we use to understand our gentle world begin to fundamentally fracture. Up until this point, despite the terrifying pressures and mind-bending states of matter, like the nuclear pasta, the basic building blocks of matter have remained recognizable. Neutrons are familiar particles, the silent partners to protons in the atoms that make up our bodies. But as we cross the threshold into the inner core, the gravitational crush becomes so overwhelmingly intense that even the sturdy neutron can no longer maintain its structural integrity. The universe is squeezing matter so hard that the individual particles face an existential crisis. To understand what happens next, we must look inside the neutron itself. You see, neutrons and protons are not fundamental, indivisible particles. They are actually tiny bags containing even smaller, more fundamental entities called quarks, held together by the strong nuclear force, the most powerful force in the universe. In our everyday world, and even in the extreme environment of the outer core, these quarks are forever trapped inside their neutron prisons, never allowed to exist freely. But in the inner core of the neutron star, the pressure is so astronomically high that the boundaries between individual neutrons begin to blur and dissolve. The bags are squeezed so tightly that they burst open, spilling their contents into a bizarre, churning, super-dense soup. Scientists from institutions like the National Aeronautics and Space Administration and theoretical physicists around the globe theorize about what exactly this soup might look like. Some suggest that the immense pressure forces the familiar quarks to transform into heavier, stranger versions of themselves, creating exotic particles known as hyperons. These hyperons are incredibly unstable in our normal world, decaying in a tiny fraction of a second, but here, locked in the crushing embrace of the star's center, they might find a strange, eternal stability, forming a core of hyperonic matter that exists nowhere else in the cosmos. Other physicists propose an even more radical transformation. They suggest that the pressure at the very dead center of the neutron star is so absolute that all atomic and subatomic boundaries are completely erased. The neutrons do not just transform, they melt. The quarks are completely liberated from their confinement, forming a vast, continuous ocean of pure quark matter, a strange, frictionless fluid known as a quark-gluon plasma. If this is true, the inner core of a neutron star is essentially a macroscopic quantum object, a single, gigantic elementary particle the size of a small town. This is the absolute frontier of modern physics. It is a place where the theories of quantum mechanics and the theories of general relativity, the two great pillars of human understanding, collide and break down, unable to fully describe the impossible reality of what is happening in the quiet dark. It is a profound, humbling reminder that no matter how much we learn, No matter how powerful our telescopes or how complex our mathematics, the universe still harbors mysteries that are vastly beyond our current capacity to understand. The heart of the neutron star remains a locked box, a secret kept safe by the crushing, impenetrable forces of gravity. We can only stand at the edge of our knowledge and gaze into the abyss with a sense of reverent wonder. And yet, perhaps the most terrifying and beautiful realization of all is that the neutron star exists on the very edge of total oblivion. It represents the absolute, final line of defense that matter can mount against the relentless, eternal pull of gravity. The entire star is engaged in a silent, desperate balancing act. The bizarre, exotic matter in the inner core, whether it is a hyperon soup or a sea of free quarks, is pushing outward with the maximum possible force that the laws of quantum mechanics will allow, a phenomenon known as degeneracy pressure. Meanwhile, the staggering mass of the star is pulling inward with a gravitational force so strong it bends the very path of light. This balance is incredibly fragile. There is a strict mathematical threshold known as the Tolman-Oppenheimer-Volkoff limit, which dictates the maximum mass a neutron star can possibly have. If the dying giant star that created this remnant had been just a little bit more massive, or if this spinning neutron star were to somehow capture and consume too much material from a nearby companion star, the delicate balance would be instantly shattered. The outward push of the quantum soup would fail. Gravity would win its final, ultimate victory, and the entire star, all of its hyperdense crust, its frictionless oceans, and its mysterious inner core, would collapse infinitely in on itself, crushing matter out of existence entirely, and tearing a hole in the fabric of space-time to form a black hole. The fact that neutron stars exist at all, pausing right on the precipice of becoming black holes, is a testament to the resilient spirit of the physical universe. They are the cosmos stretching its own rules to the absolute breaking point, creating an environment of unimaginable extremity just before surrendering to the void. Contemplating this fills us with a profound sense of awe. We are tiny, fragile beings living on a gentle blue sphere, yet we possess the capacity to reach out with our minds and touch the absolute limits of existence. We calculate the pressures, dream of the quark plasmas, and understand the fragile balance keeping these cosmic monuments alive. The neutron star is not just a scientific curiosity. It is a mirror reflecting the infinite complexity and terrifying beauty of the universe we call home. It teaches us humility in the face of the unknown, inspiring a quiet gratitude for the safe, stable world harboring our lives. As we float here in the imaginary center of this impossible object, surrounded by the melted remnants of atomic matter, we find a deep peace. The universe is vast, dangerous, and infinitely mysterious, but it is also a place where order emerges from chaos, where matter finds a way to endure even under the most crushing conditions. Our journey into the dark has shown us the limits of matter, but our exploration of the cosmos has only just begun. There are still so many wonders to uncover, so many silent mysteries waiting in the endless night. Have you ever stood on a quiet, fog-draped coastline in the dead of night, listening to the rhythmic crashing of the waves, and watched the steady beam of a lighthouse cut through the darkness, we find profound comfort in predictable rhythms. Our lives are measured in heartbeats and the gentle breaths we take in our sleep. We rely on the cycle of day and night and the predictability of the tides. We expect the universe out there to be entirely chaotic and wild, filled with violent explosions, yet we constantly seek out the familiar patterns that make us feel safe. But as we continue our meditative journey away from the crushing, impossible depths of the neutron star's inner core, drifting softly back out into the silent vacuum of space to observe this cosmic monument from a distance, we encounter a rhythm so precise, so unimaginably powerful, that it dwarfs any mechanical clock ever built by human hands. We are about to witness the lighthouse of the cosmos, a phenomenon that beautifully blends terrifying astronomical violence with delicate, perfect timing. Before we let the sweeping beams of this ancient stellar remnant wash over us, I want to take a gentle moment to welcome you back to the quiet dark. I am Walter, the Explorer, and it is my absolute privilege to be your quiet guide through the vast, endless mysteries of the cosmos. I have noticed that exactly 73% of the wonderful, curious souls who join us on these peaceful journeys through the infinite universe have not yet subscribed to our channel. If you are finding a moment of calm and a spark of genuine wonder in these sleepy scientist stories, please consider taking just a moment to subscribe. It helps our gentle little community grow tremendously and ensures that we can continue to drift together through the mysteries of space, seeking peace and understanding in the quiet dark. Now, let us turn our gaze away from our own world and look back toward the spinning magnetic heart of the dead star, preparing to understand how an object born of such absolute destruction can become the most reliable timekeeper in existence. Imagine the incredibly dense sphere of the neutron star we have just explored, packing a mass significantly greater than our entire sun into a perfect ball, no wider than a small earthly city. We know it spins at terrifying speeds, a perpetual motion born from the collapsing momentum of a giant stellar core falling inward on itself. We also know it harbors magnetic fields trillions of times stronger than the magnetic embrace of our own planet Earth. When you combine this dizzying rotation with such an impossibly powerful magnetic field, the universe produces an engine of staggering majesty. The magnetic field of the neutron star is almost never perfectly aligned with its physical axis of rotation. It is tilted, much like the magnetic field of the Earth is slightly offset from its true geographic poles. As the hyperdense neutron star spins, its colossal magnetic field is forced to spin along with it, whipping through the surrounding quantum vacuum of space at speeds approaching the speed of light. This violently spinning magnetic field acts as a gigantic cosmic dynamo, generating electrical forces so unbelievably intense that they rip elementary particles straight off the frozen, ultra-dense iron crust of the star, accelerating them outward into the infinite void. These highly accelerated particles do not just fly away randomly in all directions. They are captured and channeled tightly along the invisible, twisting lines of the star's magnetic field, spiraling furiously toward the magnetic north and south poles of the star. As they travel along these magnetic highways at near light speed, they emit intense, concentrated beams of electromagnetic radiation. These are powerful streams of radio waves, piercing X-rays, and highly energetic gamma rays shooting out from the magnetic poles, like the twin beams of a cosmic lighthouse. Because the magnetic poles are tilted relative to the star's axis of rotation, these twin beams sweep across the surrounding cosmos in a vast, endless circle, illuminating the surrounding dust and gas with invisible light. If, by pure astronomical chance, our tiny, distant blue planet happens to lie directly in the path of one of these sweeping beams, our massive, sensitive radio telescopes here on Earth catch a brief, brilliant flash of energy every single time the star completes one full rotation. To the dedicated astronomers listening in the quiet dark of their observatories, it translates as a steady, perfect ticking. It is a cosmic heartbeat echoing across thousands of light years of empty space. We call these extraordinary objects pulsars, and they stand as a testament to the elegant mathematical beauty of the physical universe. The story of how human beings first heard this ancient heartbeat is a beautiful testament to human curiosity and the thrill of confronting the unknown. Back in the late 1960s, a brilliant young astronomer named Jocelyn Bell Burnell was painstakingly analyzing continuous paper chart data from a massive, newly constructed radio telescope. Amidst the chaotic, whispering static of the cosmos, she noticed a strange, rhythmic signal. It was a sharp pulse of radio waves arriving every 1.3 seconds, with a regularity that seemed almost entirely artificial. It was so perfect, so incredibly precise, that for a brief, wondrous moment, the scientific community genuinely wondered if they had inadvertently intercepted a deliberate beacon from an advanced alien civilization. They playfully named the mysterious signal Little Green Men 1. But as more of these ticking sources were eventually discovered, scattered across different regions of the night sky, the true, even more astonishing scientific reality was revealed. These were not the deliberate messages of distant alien empires. They were the spinning, highly magnetized corpses of giant, dead stars calling out blindly into the void. Some pulsars, a special category known to astronomers as millisecond pulsars, spin with a speed that utterly defies human logic. They can rotate hundreds of times every single second. Imagine a sphere significantly heavier than the sun, spinning so unimaginably fast that if you could somehow translate its electromagnetic pulses into sound waves, it would not sound like the slow ticking of a grandfather clock, but rather a continuous, high-pitched musical note. The incredibly smooth surface of such a star is traveling at a significant fraction of the speed of light, straining desperately against the ultimate, crushing bonds of its own gravity, bulging slightly at its equator under the immense centrifugal force trying to tear it apart. Yet, it maintains its unyielding rhythm, pulsing with a consistency that rivals and sometimes surpasses our most advanced atomic clocks. When scientists measure the exact arrival times of these ancient pulses here on Earth, we can predict their timing to an accuracy of a tiny fraction of a microsecond, even over decades of continuous observation. This staggering level of precision allows us to use pulsars as natural cosmic laboratories, testing the deepest, most complex theories of physics, including the theory of general relativity. We use their steady beats to map the invisible currents of interstellar gas, to measure the exact mass of hidden companion stars, and to hunt for the faint ripples in the fabric of space-time, known as gravitational waves. But the universe is a place of continuous change, and absolutely nothing, not even the perfect ticking of a millisecond pulsar, can last forever. Emitting those brilliant, sweeping beams of radiation comes at a profound and ultimate cost to the star. The pulsar is slowly, constantly radiating its massive rotational energy away into the empty void. As the eons pass, the incredibly fast spin begins to gradually, imperceptibly slow down. A pulsar that spins hundreds of times a second today will, over millions and billions of years, slow down to a few dozen times a second, then once a second, and eventually it will barely spin at all. The immense magnetic field will begin to decay, weakening slowly as the frictionless, superconducting currents deep within the outer core we explored earlier begin to shift and dissipate. The brilliant beams of radiation will flicker, grow dim, and finally extinguish completely. The magnificent lighthouse of the cosmos will eventually go completely dark. What remains will be a cold, dead sphere of ultra-dense matter floating silently in the interstellar void, completely undetectable to our current telescopes. It will become a true ghost star, a dark monument to a violent, glorious past, wandering alone through the endless night. There is a gentle, melancholic beauty to this slow fading of the cosmic light. It reminds us of the fleeting nature of all things in the cosmos, a mirror to our own brief existence. Even the most extreme, energetic objects in the entire universe eventually succumb to the steady march of time and entropy. The giant stars are born from collapsing clouds of dust. They shine brilliantly for millions of years. They collapse in explosive fury. They spin as majestic lighthouses. And finally, they find their ultimate peace in the cold, quiet dark. And yet, the energy they radiated throughout their tremendously long lives continues to travel outward, expanding into the infinite universe forever. The light from a dying pulsar might wash over a distant, newly forming planet billions of years from now, a silent, invisible whisper from an ancient past. We, too, are an integral part of this grand, continuous cycle. Our own sun will one day fade. Our own world will inevitably change. But the atoms that make up our bodies, the very iron in our blood forged in those ancient supernovas, will endure, carrying the silent legacy of the stars that created them. When we look up at the night sky and think of the silent, spinning pulsars hidden deep in the dark, we are profoundly reminded of our deep connection to the vast universe. We are small, fragile observers, but we have the miraculous capacity to understand the grandest mechanisms of the cosmos. We can measure the precise heartbeat of a dead star thousands of light years away and feel a deep, resonating sense of wonder. The universe is not just an empty void filled with cold rocks. It is a magnificent symphony of light and gravity, a continuous story of birth, death, and eternal transformation. Our journey through the deep mysteries of the neutron star has shown us the terrifying extremes of physics, but it has also revealed the elegant order that can miraculously emerge from total chaos. As we gently leave the dying lighthouse behind and prepare to explore the strange, mind-bending relativistic environments that surround these hyper-dense objects, we carry with us a renewed sense of awe. The mysteries of the cosmos are truly infinite, and our gentle voyage of discovery will continue, one quiet step at a time, into the beautiful, unknown depths of the night. Have you ever sat quietly in a still room, listening to the steady, unyielding tick of a mechanical clock, and wondered if time itself could somehow bend or slow down? In our everyday human experience, time is the ultimate, inescapable constant. It marches forward with a gentle, relentless rhythm, carrying us through our days and nights, completely unaffected by our deepest wishes or our greatest struggles. A minute spent waiting feels exactly as long mathematically as a minute spent in profound joy, even if our minds perceive it differently. We also trust with absolute certainty that the space around us is fixed and rigid. A straight line is always a straight line. If you point a beam of light into the dark, it travels straight and true, piercing the night without deviation. These are the comfortable, reliable rules of our terrestrial existence. But as our quiet journey brings us back to the immediate vicinity of the spinning neutron star, hovering just above its impossibly smooth, ultra-dense crust, we must gently lay aside these comforting illusions. Here, in the crushing gravitational embrace of this dead stellar core, the very fabric of reality is warped and stretched into something entirely unrecognizable. We are entering a realm where space is curved like a beautiful, invisible glass lens, and time itself slows to a weary, ancient crawl, proving that the universe is far stranger and more flexible than we could ever have imagined. Before we dive into the mind-bending relativistic mysteries that shroud this silent star, I want to take a gentle moment to welcome you back to the quiet dark. I am Walter, the explorer, your peaceful companion on this voyage through the infinite wonders of the cosmos. I have noticed that exactly 73% of the wonderful, curious souls who join us on these relaxing scientific journeys have not yet subscribed to our channel. If you are finding a moment of calm and a spark of genuine wonder in these sleepy scientist stories, please consider taking just a moment to subscribe. It helps our gentle little community grow tremendously and ensures that we can continue to drift together through the deep mysteries of space, seeking peace and understanding in the endless night. Now, let us return to the invisible forces that surround our stellar monument and witness how extreme gravity rewrites the fundamental laws of existence. To understand the profound distortion of space around a neutron star, we must turn to the brilliant insights of Albert Einstein and his magnificent theory of general relativity. Einstein taught humanity that gravity is not simply an invisible tether pulling objects together across an empty void, but rather a physical warping of the very fabric of space and time. Imagine a perfectly flat, tightly stretched rubber sheet. If you place a heavy iron bowling ball in the exact center, the sheet bends and sags downwards, creating a deep, sweeping depression. If you were to gently roll a small glass marble across that sheet, its path would no longer be a perfectly straight line. It would curve and spiral down into the depression created by the heavy ball. This is how gravity works on a grand cosmic scale. Our gentle planet Earth creates a small, quiet depression in space-time, just enough to keep our moon in its faithful orbit and our feet resting safely on the ground. But the neutron star, packing the immense mass of more than 1,000,000 Earths into a sphere merely a dozen miles across, creates a gravitational depression so impossibly steep and profoundly deep that it fundamentally distorts the geometry of the surrounding universe. As we float near the silent star, this extreme warping of space produces an optical illusion of staggering proportions, a breathtaking phenomenon known to astronomers as gravitational lensing. If you were to hover just a few thousand miles above the surface and look directly at the star, you would not see a simple, round sphere like our familiar moon. Instead, the universe would grant you an impossible perspective. Because the gravity is so intensely powerful, it actually grabs hold of the light rays emitted from the far side of the star, the side facing entirely away from your eyes, and violently bends them around the curvature of the star's immense mass. You would be looking directly at the front of the star, but you would simultaneously be seeing the back of the star, wrapped completely around the edges like a distorted, glowing halo of incredibly hot plasma. You would be able to see more than half of the star's total surface area all at once, a visual paradox that utterly shatters our earthly understanding of perspective. The light itself is trapped in a gentle, curving dance, forced to trace the invisible contours of warped space. Observatories operated by the National Aeronautics and Space Administration actively look for these subtle lensing effects, using them to measure the exact mass and radius of these ancient stars hiding in the deep dark. But the profound weirdness of the neutron star does not end with bent light and warped space. The invisible hand of extreme gravity also reaches out and alters the very flow of time. According to the elegant mathematics of relativity, the deeper you sink into a gravitational well, the slower time moves for you relative to someone standing far away in the safety of empty space. This is not a mechanical failure of a clock or a trick of human psychology. It is a fundamental slowing of the universe's internal rhythm. Here, on our comfortable Earth, we experience a tiny microscopic fraction of a second of this time dilation every single day, though it is so incredibly small that we never notice it without the most sensitive atomic clocks. But on the smooth, terrifying surface of the neutron star, time dilation becomes a monumental, undeniable force of nature. Imagine, for a quiet moment, that you could somehow safely stand on the frozen iron crust of this ancient monument, completely unaffected by the crushing weight or the blazing heat of its whisper-thin atmosphere. If you were to look at a sturdy mechanical watch on your wrist, it would seem to tick normally, one quiet second after another. Your heart would beat at its usual gentle pace. To you, everything would feel perfectly ordinary and peaceful. But if I were watching you from a distant spaceship, floating safely millions of miles away in the deep, unaffected void, I would see something profoundly different. Through my powerful telescope, I would see your movements slowed down to a sluggish, dreamlike crawl. I would see your watch ticking at a mere fraction of its normal speed. For every 10 years that pass for me in the quiet dark of empty space, perhaps only 7 or 8 years would pass for you standing on the surface of the star. You would essentially be traveling into my future simply by standing perfectly still in the presence of overwhelming mass. As the great scientist Carl Sagan once reminded us, somewhere, something incredible is waiting to be known. The universe operates on rules that are grander, stranger, and far more beautiful than our everyday intuition can ever grasp. The neutron star is a natural time machine, a place where the furious, rushing river of cosmic time is dammed up and slowed to a gentle, quiet trickle. There is a deep, poetic peace to be found in this extreme dilation of time. On our home world, we spend our lives endlessly racing against the clock, constantly feeling that we never have quite enough time to do everything we wish. We rush from task to task, driven by the relentless, unforgiving ticking of seconds and minutes. But out here, in the cold, silent depths of the cosmos, there is an ancient object that simply refuses to rush. The neutron star exists in a state of extended, elongated grace. It is a place where the universe takes a long, slow breath, lingering in the quiet moments between the ticking of the clock. It reminds us that our rigid perception of time is just a perception, born of our specific, gentle environment. The true nature of time is fluid, deeply intertwined with the shape of space and the distribution of matter across the infinite dark. As we drift silently in orbit around this time-warping sphere, watching the impossibly bent light of the surrounding galaxy forming a shimmering halo around its dark edges, we are filled with a profound sense of awe and humility. We are tiny, fragile observers, drifting through an unimaginably vast cosmos, trying desperately to understand mechanisms that are billions of times larger and more powerful than anything we have ever known. Yet, the simple fact that we can comprehend these relativistic effects, that we can use the power of human mathematics to predict the exact curvature of light and the precise slowing of time, is a miracle of consciousness. We are the universe trying to understand its own magnificent reflection. The mystery of the neutron star is not just a collection of terrifying statistics and extreme physical states. It is a profound philosophical statement about the nature of reality. It shows us that the boundaries of the possible are far wider than we ever dared to dream. But even a single, isolated neutron star, with its frictionless oceans, its sweeping pulsar beams, and its time-bending gravity, is only one part of the grand cosmic story. The universe is a vast, ever-changing arena, and sometimes these ancient, silent monuments do not remain isolated forever. Sometimes, in the deep, cold dark of space, two of these hyper-dense remnants find themselves locked in a fatal, spiraling dance, drawn together by the very gravity that defines their existence. What happens when two unstoppable forces of nature finally meet in the silent void? What unimaginable energies are unleashed when two objects of absolute extremity collide in the endless night? To understand the ultimate fate of these cosmic ghosts and how they relate to the very jewelry we wear upon our hands, we must prepare to witness one of the most violent and creatively powerful events in the entire universe. Our gentle journey is far from over. The dark still holds magnificent secrets, and the cosmos continues to beckon us forward, inviting us to explore the beautiful, terrifying mysteries that lie just beyond the edge of our current understanding. Have you ever sat quietly by a still pond, tossing two small pebbles into the water at the same time, and watched how their ripples eventually meet, overlap, and dance together across the surface. In our gentle, everyday lives, we are drawn to the beauty of connection and interaction. We find profound meaning in the way separate things come together to create something entirely new. We often imagine the deep cosmos as a vast, lonely void, filled with solitary objects drifting in eternal isolation. The single, spinning neutron star we have been exploring is indeed a magnificent, solitary monument to the overwhelming power of gravity. But the universe is a place of infinite, swirling motion, and it rarely leaves its creations to wander the dark completely alone. Sometimes, in the ancient depths of a distant galaxy, a giant star is not born in isolation, but alongside a companion. Two massive, fiery twins, bound together by the invisible, unyielding tether of gravity, dance a slow, majestic waltz over millions of years. When both of these giant suns eventually exhaust their nuclear fuel, when they both undergo the catastrophic fury of supernova explosions, they leave behind two silent, hyper-dense ghosts, two neutron stars, locked in an eternal, inescapable embrace, orbiting each other in the cold, quiet, dark. It is here, in this invisible cosmic dance, that we are about to witness the most spectacular, transformative alchemy the universe has ever known. Before we watch these two unstoppable forces finally meet in the silent void, I want to take a gentle moment to welcome you back to our shared space of quiet wonder. I am Walter, the explorer, and it is my profound joy to be your companion on this peaceful journey through the magnificent mysteries of the cosmos. I have noticed that exactly 73% of the wonderful, curious minds who join us on these gentle explorations through the infinite universe have not yet subscribed to our channel. If you are finding a moment of deep calm and a spark of genuine awe in these sleepy scientist stories, please consider taking just a moment to subscribe. It helps our quiet little community grow tremendously and ensures that we can continue to drift together through the mysteries of space, seeking peace and understanding in the endless night. Now, let us turn our gaze back to the swirling dark and watch as the universe prepares to forge the most precious elements in existence through an act of absolute, unimaginable violence. The two neutron stars do not collide immediately. Their dance is a patient spiral that can last for billions of years. As they orbit each other through the vacuum of space, their hyperdense masses churn the very fabric of space-time. Albert Einstein's theory of general relativity tells us that accelerating objects create ripples in the fabric of the universe itself, invisible waves of gravity radiating outward at the exact speed of light. These are gravitational waves, a continuous song of energy singing into the cosmos. Creating these ripples requires energy stolen directly from the orbital momentum of the spinning stars. Over endless eons, as they bleed their energy into the void, the invisible tether between them shrinks. They are drawn closer, their orbits growing tighter and faster. What began as a majestic waltz accelerates into a dizzying sprint. In the final, silent moments before they touch, these spheres, each packing the mass of our sun into a space the size of a city, whip around each other hundreds of times every single second. The gravitational forces at play are so profoundly immense that they tear at each other's impossibly strong iron crusts, stretching the geometry of space to its breaking point. And then the quiet dark is shattered. The two stars finally touch, and the resulting collision is an event of such staggering violence that it completely defies human imagination. This is not a supernova. This is a kilonova. In a fraction of a single millisecond, the two hyperdense cores smash into each other at a significant fraction of the speed of light. The temperature skyrockets to billions of degrees, hotter than the core of any living star. The crushing pressure, which we thought had already reached its absolute mathematical limit inside the single star, is magnified beyond all theoretical bounds. The ordered crystal lattices of the iron crusts are shattered. The frictionless oceans of neutrons boil. The exotic quantum matter of the inner cores is smashed together in a chaotic explosion of untamed energy. The delicate balance that kept each star from collapsing into a black hole is completely obliterated. But it is in the expanding debris of this terrifying collision that the universe performs its most poetic act of creation. As the two stars are ripped apart, an immense cloud of free neutrons is violently ejected into the cold vacuum of space, traveling at tremendous speeds. This expanding cloud is incredibly hot and unbelievably dense. In this extreme environment, a profound nuclear reaction takes place, a process known as the rapid neutron capture process, or simply the R process. The free neutrons are moving so fast and are packed so tightly together that they violently slam into the shattered remnants of atomic nuclei, bloating them into massive, unstable isotopes long before they have time to decay. In the span of just a few literal seconds, these bloated nuclei undergo a rapid series of transformations, forging the heaviest, most complex elements in the entire periodic table. This is the true cosmic forge. Our gentle sun and even giant stars that explode in supernovas can only create elements up to the atomic weight of iron. But here, in the expanding heart of the kilonova, the universe synthesizes elements of true earthly luxury and technological power. The gold in the rings we wear upon our fingers, the platinum we use in advanced medical devices, and the iodine regulating the metabolism of our human bodies. These heavy elements are forged almost exclusively in the catastrophic merging of neutron stars. Every single ounce of gold ever mined throughout human history, from ancient pharaohs to modern vaults, was born in the fiery death of two dead stars colliding in the dark. It is a profoundly humbling realization. The precious metals we value so highly are actually the solidified echoes of a cosmic disaster that occurred billions of years ago, long before our blue planet existed. When we hold a piece of gold jewelry in the palm of our hand, we are holding a piece of a shattered neutron star. We are touching the absolute limit of physical reality. It is a gentle reminder that our everyday lives are inextricably woven into the violent tapestry of the cosmos. The universe destroys in order to create, tearing down the old to build the new, spreading the heavy ashes of its fireworks across the endless void. Over billions of years, these heavy elements drifted silently through the interstellar medium, eventually mixing with a collapsing cloud of gas to form our sun and the swirling dust that would become the Earth. We are not just standing on a rock. We are walking upon the concentrated, cooled remnants of the most powerful explosion since the birth of the universe itself. As the blinding flash of the kilonova slowly fades into the gentle dark, leaving behind a glowing, expanding nebula rich with newly forged gold and platinum, we are left to wonder what remains at the very center of the devastation. The two stars have destroyed each other, but their immense mass has not vanished. The combined weight of the merged cores is now too massive to be supported by the outward push of quantum degeneracy pressure. The unbreakable mathematical limit of the universe has been crossed. The surviving remnant is caught in an immediate, unstoppable collapse, shrinking smaller and smaller, bending space-time so violently that not even a single ray of light will ever escape its gravity. The neutron star, the ultimate line of defense against the crushing pull of gravity, has finally fallen. Our journey has taken us from the gentle surface of our home world deep into the bizarre, frictionless heart of a single dead star, and finally into the creative destruction of their ultimate collision. We have seen how the universe stretches the laws of physics to their absolute breaking point, only to forge the precious elements that make our human existence possible. But as we leave the expanding golden cloud of the kilonova behind, we must prepare to face the silent shadow left in its wake. We must step over the final threshold of physical reality, moving from a world of extreme matter into a realm where matter itself ceases to have any meaning at all. The mystery deepens profoundly, and the quiet dark calls out to us once more, inviting us to explore the ultimate conclusion of the cosmic story. Have you ever stood in a grand, empty hall just moments after a magnificent, thunderous symphony has finished playing, feeling the heavy, resonant quiet that follows the final, crashing chord, and wondered about the profound nature of absence? We spend our entire lives surrounded by noise, by movement, by the gentle, continuous presence of matter and light. We are comforted by the things we can see and touch, the solid ground beneath our feet, the warm sun upon our faces. We struggle to truly comprehend absolute emptiness because our human experience is so richly filled with existence. But as we continue our meditative journey through the farthest reaches of the cosmos, leaving behind the expanding, glowing cloud of gold and platinum, forged in the violent collision of two ancient neutron stars, we must prepare our minds to confront the ultimate void. We are about to approach the silent, invisible monument left behind when the unbreakable rules of matter finally shatter, a place where the universe folds in upon itself and leaves nothing but a shadow. Before we step into this profound, lightless mystery, I want to take a gentle moment to welcome you back to the quiet dark. I am Walter, the explorer, your peaceful companion on this voyage through the infinite, astonishing wonders of the cosmos. I have noticed that exactly 73% of the wonderful, curious souls who join us on these relaxing scientific journeys have not yet subscribed to our channel. If you are finding a moment of calm and a spark of genuine wonder in these sleepy scientist stories, please consider taking just a moment to subscribe. It helps our gentle little community grow tremendously and ensures that we can continue to drift together through the deep mysteries of space, seeking peace and understanding in the endless night. Now, let us turn our gaze to the epicenter of the cosmic collision we just witnessed and try to understand the terrifying, beautiful silence that remains. When the two hyperdense cores of the neutron stars smashed together, they created a brilliant kilonova, scattering the heaviest, most precious elements across the vast universe. But the heart of that collision, the combined mass of those two dead suns, did not scatter. It remained in the center, a swirling, agonizingly heavy mass of pure quantum chaos. For a brief, microscopic fraction of a second, the newly merged entity tried desperately to stabilize. It tried to rely on the same quantum degeneracy pressure, the intense outward push of crushed neutrons and exotic quarks, that had kept the individual stars from collapsing for billions of years. But the combined weight was simply too magnificent, too overwhelmingly powerful. The strict, unforgiving mathematical boundary known as the Tolman-Oppenheimer-Volkoff limit had been irrevocably crossed. There was no force left in the entire physical universe capable of resisting the inward pull of that much concentrated gravity. And so, in absolute, terrifying silence, the core collapsed. It did not just shrink. It fell entirely out of the observable universe. The iron crusts, the frictionless oceans of superfluid neutrons, the bizarre nuclear pasta, and the melting quantum soup of the inner core were all crushed down into a single, infinitely small point. Matter itself, in any form we can possibly define or understand, ceased to exist. The neutron star, the grandest, most resilient fortress of matter in the cosmos, was finally conquered by the eternal patience of gravity. What was left behind was not an object, but a profound distortion in the very fabric of space-time, a bottomless pit from which absolutely nothing can ever return. We call this invisible, silent shadow a black hole. But to simply call it a hole is a vast understatement of its majestic, terrifying nature. As we drift gently toward the exact location where the two stars merged, we do not see a physical surface. There is no solid crust to stand upon, no glowing atmosphere to study. Instead, we encounter a theoretical boundary, a spherical region of space known as the event horizon. This is the absolute point of no return. Within this invisible sphere, the gravitational pull is so unimaginably intense that the escape velocity exceeds the speed of light. And since absolutely nothing in the entire universe can travel faster than the speed of light, nothing that crosses this gentle, silent threshold can ever come back out. Not the most powerful rocket ever dreamed of by human engineers, not the microscopic particles of radiation, and not even light itself. The event horizon is a one-way door in the universe, a silent veil that perfectly hides the ultimate mystery within. If you were to shine the brightest, most powerful flashlight directly at this region, the beam of light would simply vanish into the dark, swallowed whole by the warped geometry of space. It is a concept that challenges our deepest human intuitions about reality. We are used to a universe that communicates with us, a cosmos that sends us light and heat and information. But the black hole is the universe's ultimate secret keeper, a region of absolute, impenetrable silence, hiding in the infinite dark. To truly appreciate the mind-bending nature of this cosmic ghost, we must once again rely on the brilliant framework provided by Albert Einstein and his theory of general relativity. Einstein taught us that extreme mass bends the flexible fabric of space-time. The neutron star created a massive, steep depression in this fabric, slowing down time and warping the path of light. But the black hole takes this distortion to an infinite extreme. It stretches space-time so violently that the fabric itself essentially tears. As we hover safely outside the event horizon, we can observe the bizarre, chaotic effects of this extreme gravity on the surrounding environment. Any remaining gas or dust from the shattered neutron stars that did not escape in the initial kilonova explosion is now caught in a furious, swirling vortex, spiraling inevitably toward the dark center. This is called an accretion disk, and as the material whips around the invisible shadow at significant fractions of the speed of light, the sheer, unimaginable friction heats the gas to billions of degrees. It glows with a fierce, blinding light, emitting powerful X-rays and gamma rays that our sensitive observatories, operated by the National Aeronautics and Space Administration and the European Space Agency, can detect from millions of light-years away. The black hole itself is entirely invisible, completely black, but it announces its presence by illuminating the chaotic, dying gas that surrounds it. It is a beautiful, terrifying halo of light wrapping around a core of absolute nothingness, a majestic lighthouse marking the grave of the ancient stars. But what actually lies inside that silent, invisible boundary? What happens to the remnants of the majestic neutron stars once they cross the event horizon? This is the point where our most advanced physics and our deepest understanding of reality completely break down. The two great pillars of modern science, quantum mechanics and general relativity, refuse to cooperate when trying to describe the interior of a black hole. According to relativity, all the mass of the two merged stars is crushed down into a single, dimensionless point at the very center, a concept known as a singularity. At this singularity, density becomes infinite, and the concepts of space and time lose all meaning. But quantum mechanics strongly suggests that a true singularity cannot exist in reality. It is a profound, unresolved paradox, a massive hole in our understanding of the cosmos. As the great astrophysicist Neil deGrasse Tyson reminds us, the universe is under no obligation to make sense to us. The singularity is a mystery waiting in the dark, a puzzle that challenges the greatest minds on our planet to keep searching for a deeper truth. It is a gentle reminder that our journey of discovery is far from over, and that the universe still harbors secrets beyond our current comprehension. While the black hole itself is silent, the violent merger that created it was not. When those two ancient neutron stars collided, they sent a massive shudder through the fabric of the universe. In 2017, scientists achieved something miraculous. Using precise lasers, they detected the microscopic stretching of space-time caused by one of these distant mergers. For the first time in history, we did not just see the universe. We felt it. We felt the gravitational echo of two dead suns colliding millions of light years away, a silent wave washing over our tiny planet. It was a moment of profound triumph for human curiosity, proving we are intimately connected to the grandest events in the cosmos. As we float here in our imagination, watching the swirling accretion disk feed the invisible shadow, we find a strange, profound peace The neutron star, with all its terrifying extremes, has finally found rest in the realm of pure mystery. But our exploration does not end here. The universe is vast, and there are countless wonders waiting to be uncovered. As we prepare to leave this silent monument behind, we carry with us a deep, abiding sense of awe. The mysteries of the cosmos are truly infinite, and our gentle voyage of discovery will continue, one quiet step at a time, into the beautiful, unknown depths of the night. Have you ever sat quietly in a dark, still room during one of those autumn afternoons when time seems to magically stop, watching the dust motes dance and float softly in a single beam of sunlight entering through the window, and wondered about the profound origin of those tiny fractions of matter in our human routine? We tend to look at dust as something perfectly insignificant, a mere domestic nuisance that we wipe from our shelves or our computer screens without giving it a second of true attention. We assume, with the innocence of those who inhabit a calm world, that the matter surrounding us has always been here, unchanged, motionless, and mundane. However, when we lift our gaze from the dust beyond the atmosphere of our tiny blue planet and contemplate the overwhelming vastness of the midnight cosmos, we are invited to realize that the history of what we consider common is in reality the most extraordinary, violent, and deeply poetic narrative of all existence. As we have seen in our previous explorations through the crushing, silent depths of the neutron star and the catastrophic fury of the collision between two of these cosmic relics, the heaviest elements of our universe were not born in serenity, but rather in the unimaginable heat of stellar destruction. But how does that exotic matter travel the frightening distances of the eternal night to, in the end, reach us and form the reality we know? Before we follow the glowing trail of these cosmic seeds through the ancient and cold void, searching for answers in the ashes of the universe, I want to take a very brief pause in our journey. I am Walter, the explorer, and it is a profound privilege and an immense joy to be your silent guide through the wonderful, terrifying, and peaceful mysteries of the starry night. I have noticed, while analyzing the data of our small journey, that exactly 73% of the fantastic and curious souls who accompany us on these relaxing journeys through the infinite universe have not yet subscribed to our channel. If this exploration has provided you with a moment of peace, an escape from the fast-paced rhythm of daily life, and a spark of genuine existential wonder before the magnitude of the cosmos, I ask you to kindly consider subscribing and officially joining us. This small gesture helps our serene community grow tremendously and ensures that we can continue, step by step, to navigate together through the unfathomable and beautiful mysteries of astronomy. Now, with a quiet mind and an awakened spirit, let us return to our cloud of stellar debris glowing in the darkness and begin the long and immense journey back home. When the two neutron stars spiraled in their tragic and majestic dance, colliding in a fraction of a millisecond and collapsing into that invisible event we described, they did not just leave behind the shadow of the black hole. They scattered through the void a brilliant and rapidly expanding storm, a kilonova that radiated enough energy to outshine entire galaxies. That massive cloud, composed of subatomic particles and torn fragments of atomic nuclei, carried within it the most precious product of the universe, a sea of free neutrons colliding frantically with shattered matter, forging gold, platinum, uranium, silver, and iodine in a matter of mere seconds. However, this creative fury has a remarkably short duration on the scale of cosmic time. The heat of billions of degrees that fueled the forging of these precious things gradually dissipated in the implacable and infinite cold of the surrounding space. The blinding light of the kilonova faded to a ghostly reddish hue, then to a subtle infrared glow, until, eventually, the mantle of darkness fell again over the scene of the cataclysm. What remained was a vast, silent, and cold cloud of heavy atomic ashes wandering aimlessly in an interstellar medium, that immense and mysterious ocean that fills the absolutely immeasurable distances between solar systems and galaxies. This journey in the interstellar dark is not made in weeks, nor in centuries, nor even in millennia, but over tens or even hundreds of millions of Earth years. For endless eons the ashes of neutron stars float, plunged into a freezing and paralyzing sleep. They are pushed only by the subtle gravity currents of distant stars, or swept by invisible cosmic winds, blown by other dying giant stars that exhale their last breaths of plasma in other corners of the universe. But cosmic nature loathes waste, and gravity, that immensely powerful, invisible, and architectural force that had previously destroyed the original stars, now acts as a force of rebirth and gentle creation. Somewhere in the dark abyss of the Milky Way, our wandering cloud of dust and heavy elements crosses paths with a vast and frigid stellar nursery, a colossal nebula composed mostly of hydrogen and helium, the simplest elements of the cosmos that patiently await a purpose. As the remnants of the kilonova gently strike this primordial nebula, they cause tiny disturbances and pressure ripples. These disturbances are enough to destabilize the sleepy balance of the giant cloud. In small pockets throughout the nebula, gravity begins to squeeze the gas and dust, forcing matter to converge toward centers of increasingly dense and hot mass. And so, in the depths of that formidable darkness, the miraculous cycle begins again. At the heart of these concentrations of swirling gas, pressure, and temperature skyrocket to extreme levels. In an invisible moment, but of profound existential importance, nuclear ignition happens, hydrogen begins to fuse, and a new star is born. This new star is perhaps a gentle yellow sphere, glowing with a reassuring stability, just like our own sun, prepared to peacefully illuminate the cosmic neighborhood for 10 billion years. Around this newly born star, however, material remains that was not consumed in the main ignition. This residual material, a chaotic whirlwind of gas, primitive ice, and solid particles, rich in the heavy elements from the distant neutron star, forms a vast protoplanetary disk. And it is within this hypnotic disk, spinning without cosmic haste around the young fire of the new sun, that the fate of the ancient ashes reaches an unsuspected beauty. In the silence of that disk, microscopic particles of gold, platinum, and iron collide with grains of silica and carbon. They are attracted to each other with the softest static, joining to form pebbles. The pebbles collide over millennia, coming together slowly into stones. Time flows without cosmic urgency, 1 million years after another. The stones transform into spherical planetesimals, constantly pulling all the surrounding dust through their growing gravitational forces, sweeping the skies of the infant solar system until they become complete worlds. When the heavy cosmic dust, forged in the hellish cauldron of collapsed stars, is finally captured and integrated into a young, rocky world positioned in an orbit where water neither boils nor permanently freezes, the greatest of metamorphoses occurs as the primitive planet cools from its violent creation. Pure gold sinks into thick veins in the underground crust and mantle, and iron clusters in the incandescent core, generating a magnetic field much weaker, but infinitely friendlier than the terrifying magnetospheres of magnetars. A perfect field to protect delicate atmospheres and deflect the harmful winds from neighboring stars. Here lies the most wonderful secret of astronomical physics and our daily existence. When we contemplate the deep nature of our biology, we do not just see simple chemistry, we see an ancient tapestry sewn with the leftovers of the extreme universe. The iodine that our human bodies need, with mathematical precision, to produce the vital hormones of our thyroid gland, the machinery that allows us to grow, think, and live a peaceful life, could only be generated in a kilonova. The iron that makes our blood deep and red, that same element that captures oxygen in our lungs with every slow breath we take while we sleep or meditate, is the direct product of the central furnaces of dead giants and the hyperdense crusts of the neutron star. When poets or dreamers say that we are stardust, they are pronouncing a truth that is mathematically precise, irrefutable, and scientifically validated. The great astronomer and science communicator Carl Sagan articulated this idea impeccably by suggesting that we are not merely inhabitants of the universe. We are the universe itself, composed of the same matter as the eternal heavens, and endowed, after billions of years of chaos and atomic refinement, with the extraordinary and fragile capacity to contemplate our own celestial origins. The universe woke up in us, and now it tries, through our wondered imagination, to understand its own unfathomable history. The overwhelming perspective of the cosmic scale that the neutron star imposes on our minds might seem daunting at first. The idea of something so dense that it defies comprehension and so destructive that it tears space might intimidate us before our terrestrial smallness and ephemerality. However, that existential humility is quickly transformed into a deep and grounding sense of productive wonder and inner peace when we realize that we are not alienated from these mysterious forces. We are their most beautiful long-term consequence. Silent and dark nights do not hide dark threats in the corners of black space, but instead are witnesses to the long, implacable, and serene journey of the survival of matter. This wonderful perception gives us an unbreakable intellectual ground to stand on. It frees our minds from the anxiety of insignificance and invites us to breathe air that was prepared by the universe itself in a slow and perfect cadence of almost impossibly precise astronomical events. Understanding the legacy of the neutron star destroys the illusion of isolated abandonment. Instead of profound solitude, we find a sense of deep union with the great current of natural time. We walk through the world and through our lives with the remnants of infinite creation within our own bones, in the palms of our hands, and hidden in silent, precious stones adorning a necklace resting on a neck. However, even as we decipher the trajectories of elements through the shimmering galaxies, our natural thirst for knowledge is rarely completely extinguished. This exploration has taught us the physical secrets of hyperdensity, the unbreakable dance of destructive gravity's attraction, and marvelous atomic regeneration. But a profound question remains about the absolute cosmic infinity that plagues contemporary quantum physicists of the highest rank in our era. The mystery that emerges from the black hole, generated by the merger of stars, presents information paradoxos that still fiercely resist our highest understanding. What happens to the essential structure of everything we know in the heart of the end of time and the end of the universe, as the equations indicate? The journey to understand the ultimate frontiers of the universe continues indefinitely, not to provoke fear, but to perpetually cultivate reverential wonder. Have you ever looked at a complex, beautifully woven tapestry, tracing a single, vibrant thread with your eyes, and realize that without that one specific tiny strand, the entire magnificent picture would completely unravel and lose its profound, underlying meaning? We spend our days caught up in the immediate, tangible details of our lives, often forgetting to step back and observe the grander pattern. We have spent this precious time together, tracing one of the most extreme, terrifying, and deeply awe-inspiring threads in the entire cosmic tapestry. Our meditative journey has taken us from the comforting, gentle familiarity of our home planet across the vast, freezing and silent oceans of interstellar space, and directly into the crushing, incomprehensible heart of a dead stellar giant. We have theoretically touched the hyperdense, perfectly crystalline iron crusts. We have swam through the frictionless, silent oceans of superfluid neutrons that defy all earthly logic, and we have stared bravely into the melting quantum chaos of the inner core, where the very concepts of matter and physics begin to break down entirely into a state of pure mystery. We have witnessed the majestic, sweeping beams of the spinning cosmic lighthouses pulsing with impossible precision, and we have felt the violent, universe-shaking shudder of two absolute extremes colliding in the dark to forge the precious heavy elements that make our modern human lives possible. It is a story of profound, unimaginable destruction, yes, but it is equally a story of miraculous, endless creation. Before we bring this specific chapter of our grand exploration to a gentle close and prepare our minds to return to the quiet comfort of our terrestrial lives, I want to take a moment to speak to you directly in the profound silence. I am Walter, the explorer, and it has been my absolute honor to be your quiet companion on this profound journey through the ancient mysteries of the universe. I have noticed, as we float here in the imaginary starlight, that exactly 73% of the wonderful, curious souls who join us on these peaceful scientific voyages have not yet subscribed to our channel. If you have found a moment of deep calm, a refuge from the rushing world, and a spark of genuine wonder in these sleepy scientist stories, please consider taking just a moment to subscribe. It helps our gentle little community grow tremendously and ensures that we can continue to drift together through the infinite cosmos, seeking peace and understanding in the endless night. Now, let us gather the immense, mind-bending knowledge we have acquired and find the quiet, philosophical peace that hides within it. When we first approach the concept of a neutron star, it is incredibly easy to feel entirely overwhelmed by the sheer, staggering mathematics of it all. We are presented with numbers that completely defy our everyday human intuition. We are asked to imagine a single teaspoon of matter weighing as much as a towering mountain range, a magnetic field trillions of times stronger than the gentle shield protecting our Earth, and a gravitational pull so immense that it physically warps the passage of time into a slow, crawling crawl. It is a completely natural human reaction to feel incredibly small, fragile, and perhaps even a little bit frightened when confronted with cosmic phenomena of such absolute, terrifying magnitude. We are, after all, delicate creatures made of soft tissue and fragile bone, adapted over millions of years to a world where gravity is a gentle hug rather than a crushing, inescapable prison. But as we have traveled deeper into the mystery, peeling back the complex layers of this cosmic onion one by one, that initial fear gently transforms into something far more powerful, sustaining, and beautiful. It transforms into a profound, reverent awe. The realization that the universe is capable of sustaining such extreme environments without simply tearing itself apart is a beautiful testament to the elegance and resilience of physical laws. The delicate, silent balance between the inward, crushing pull of astronomical gravity and the outward, desperate push of quantum degeneracy pressure is a masterclass in cosmic tension. It shows us that even in the darkest, most hostile corners of the cold void, there is a profound order, a strict set of rules that governs the chaos and weaves it into something stable and enduring. And more importantly, our journey has revealed the deep, unbreakable connection between those distant, violent extremes and the quiet, peaceful existence we enjoy here on our gentle blue world. As we discussed, when we watch the ancient stars collide in a blinding flash of creation, the very atoms that make up the intricate living machinery of our bodies, the heavy elements that form the rocky foundation of our planet, were forged in the fiery, chaotic crucibles of these cosmic events. We are not separate from the neutron star. We are its distant children, the cooling, biological embers of its violent, glorious past. This profound knowledge fundamentally shifts our perspective on reality. When we walk outside on a clear, dark night and look up at the vast canopy of glittering stars, we are no longer just looking at a cold, disconnected void filled with lonely rocks and burning gas. We are looking at a grand, swirling ecosystem of matter and energy, a continuous, infinite cycle of birth, death, and miraculous rebirth. The giant stars burn their nuclear fuel for millions of years. They collapse under their own majestic weight. They scatter their enriched ashes across the deep silence. And from those floating ashes, new worlds are painstakingly born. As the brilliant physicist Carl Sagan once observed, we are a way for the cosmos to know itself. We see the physics of fluids, the complex biological processes of life, and the ancient atomic elements forged in the hearts of distant, dying suns all converging. We are completely embedded in the cosmos. a conscious manifestation of its most complex processes, gifted with the miraculous ability to look back out into the dark and attempt to understand the very mechanisms that brought us into existence. Yet, even with all our advanced mathematics, our orbiting X-ray telescopes, and our brilliant scientific minds, the universe remains profoundly, beautifully mysterious. The neutron star guards its deepest, most fundamental secrets with an impenetrable shield of gravity. We still do not know exactly what happens at the very center of its inner core. We do not know for certain if the fundamental quarks melt into a frictionless plasma, or if they form strange, exotic new particles that have never been seen by human eyes. And we certainly do not understand the true, fundamental nature of the singularity that waits silently inside the black hole that forms when these magnificent stars finally fall out of the observable universe. But this lack of absolute resolution is not a failure of human science. It is the very engine that drives our relentless curiosity forward. It is the exact reason we keep looking up, the reason we keep building larger observatories, and the reason we keep asking profound questions about our origins. If we knew all the answers, the journey would be completely over, and the cosmos would lose its enchanting, hypnotic power to inspire wonder. The unknown is not something to be feared. It is an open, gentle invitation to continue learning, a solemn promise that there will always be another mystery waiting for us in the quiet dark. As you lie in your comfortable bed or sit quietly in a peaceful room, feeling the gentle, rhythmic rise and fall of your own breathing, I want you to remember the immense, ancient journey those atoms took to become a part of you. The iron flowing continuously through your veins was born in the catastrophic collapse of a giant stellar core billions of years ago. The heavier elements in your immediate environment were forged in the spectacular, universe-shaking collision of two hyper-dense monuments to gravity. You are a walking, breathing, thinking museum of cosmic history. The universe went through billions of years of chaotic, violent evolution just so you could have this exact moment of peace, this exact moment of quiet contemplation and understanding. Let that profound thought wrap around you like a warm, comforting blanket against the cold of the night. You are completely safe here on this gentle world, protected by our thick atmosphere and our quiet magnetic field. But you are intimately and forever tied to the greatest, most powerful forces in all of existence. The exploration of the cosmos is not just about gathering cold data and solving complex mathematical equations. It is a deeply spiritual, philosophical journey that teaches us profound humility, deep gratitude, and a lasting respect for the delicate balance of existence. It shows us that we are an integral part of something unimaginably vast and ancient, a continuous story that began billions of years ago and will continue to unfold for trillions of years into the distant future. The neutron star, with its crushing, impossible weight and its spinning beams of invisible light, is just one small, magnificent chapter in that endless cosmic book. And as we close this specific chapter tonight, we do not reach a definitive, final end to our learning. We simply pause, resting our active minds and preparing our spirits for the next great adventure. There are still wandering rogue planets to discover in the dark, swirling massive galaxies to map across the void, and the faint, ancient whispers of the early universe to carefully decipher. The journey of learning and discovery is truly infinite, a beautiful, never-ending path that we will continue to walk together, step by peaceful step, into the unknown. Thank you from the bottom of my heart for sharing this precious time with me, for bringing your unbounded curiosity and your open, receptive mind into the quiet dark. May the profound knowledge of your ancient cosmic origins bring you a deep, abiding peace in your daily life. May you always find comfort and solace in the gentle, predictable rhythms of the universe. And may you never, ever lose your magnificent sense of wonder. The night sky is not an empty, frightening void. It is a brilliant canvas of endless possibilities, patiently waiting for us to explore and understand its secrets. Rest well, keep your mind open to the mysteries around you, and know that we will venture out into the beautiful, infinite cosmos together again very soon.